Welcome to this lesson on the specification pattern. You will learn how to take the messy conditional logic that encodes your business rules and package it into small focused objects that can be combined, reused, and reasoned about independently. By the end, you will recognize this pattern in a code base and know exactly when to reach for it. Imagine you are building an e-commerce platform. The rule, a product is eligible for a flash sale, might involve checking stock level, price, and category. That logic often ends up hard-coded inside a repository filter, then copied into a validator, then duplicated again inside a notification service. Every time the rule changes, you hunt down 3 different places. That is the pain this pattern was designed to cure. Think about a job listing. It does not hard-code one giant screening function. Instead, HR writes individual criteria, years of experience, education, portfolio, and then combines them, this and that, or this or that, but not the other thing. Each criterion is a self-contained, named rule. The specification pattern works exactly the same way. Each business rule becomes its own object and you compose them like building blocks. The core idea is one interface. A specification has a single method called isSatisfiedBy that receives a candidate object and returns true or false. Concrete specifications implement real business rules. Then 3 composites, and spec, or spec and not spec, each accept other specifications and combine them. The entity being tested knows nothing about the rules. The rules know nothing about where they will be used. That clean separation is the entire point. Start at the top. The specification interface declares isSatisfiedBy plus 3 builder methods, and, or, and not. Base spec provides those 3 methods, so every concrete spec inherits them for free. And spec stores 2 child specs, and returns true only when both are satisfied. OR spec returns true when either is. Not spec inverts a single spec. Then 3 concrete leaf specs, affordable spec, in-stock spec, and electronic spec, each encode one business rule. Down in the client we chain dot and to combine affordable spec with in-stock spec, then dot and again with the result of electronic spec dot not, meaning the product must not be electronics. That single composed object is passed to array filter as the predicate. The product with price 35 in stock, in the books category, is the only one that passes all 3 gates. When you call isSatisfiedBy on a composite like nspec, it simply calls isSatisfiedBy on each of its children and combines the results. This forms a tree at runtime. The real power is that any spec object, whether a leaf or a composite, satisfies the same interface, so you can pass it to a repository for database filtering, to a domain service for validation, and to a factory for construction guards, all without duplicating the rule. The key trade-off is class proliferation. Each distinct rule becomes its own class, which is great for a rich domain, but noisy for simple one-off conditions. Reach for specification when the same rule surfaces in 3 different parts of the codebase, when rules are combined on the fly based on user input, or when each rule deserves its own unit test and documentation. Skip it when you have a single stable filter that a 2-line arrow function handles perfectly well. Also be aware that while specification works cleanly for in-memory filtering, translating it to SQL queries requires a separate layer. The pattern itself does not solve that automatically. To summarize, the specification pattern lifts business rules out of entities and services and turns them into first-class objects with a single evaluation method. You compose those objects with and, or, and not to express complex logic without nested conditionals. Because every specification shares the same interface, you can reuse one rule object everywhere it applies. Reserve it for domains where rules are genuinely reusable and combinable. And for simpler needs, a plain function is still the right tool.